Today we're going to talk about simple loops, and I thought we would do that on the windy side of Stony Point. You can see here the surf is up. Just a word of advice though, if you're going to do this, don't be like me. Invest in that waterproof case before you start taking the pictures. Okay, today we're going to do some simple loops. Loops are repetition control structures. They allow us to do statements over and over and over again. And the simplest of all of them is probably the while loop. While a particular Boolean expression is true, then the statements inside the body of the loop are repeated. The body of the loop is identified by the two curly braces. We're used to those now. And the Boolean expression is just some kind of a condition that's evaluated to see if it's true or false. So then the way it works is when the program reaches the while loop, it looks at the expression. If the expression is true, it goes into the loop and does the statements one time. Then it comes back to the top of the loop, and if the expression is still true, it does the statements inside the loop again and comes back to the top. And if the expression is still true, it does the statements again. So we repeat the statements over and over again until finally the Boolean expression at the top of the loop is no longer true. Watch out with while loops. You put semicolons at the end of statements that are inside the loop, but don't put any other semicolons around it. Don't put them after the while condition or anything else. Here's a typical loop. We have a variable called answer that contains a single character. We ask the user, are you ready? And they type in yes or no. We read that character and then we get to the loop. Now they might have typed in a lowercase y for yes, or they might have typed in an uppercase y. We don't know. So the while loop is going to do this. It's going to change the answer they gave us to uppercase and then compare it with an uppercase y. And if it's equal to an uppercase y, if that's true, then we get to go in. We pass the entrance test, we get to go into the while loop, and then we do whatever it wants us to do. We read in the data, we process the data, we print the results. Once we finish that, we ask the user again, do you want to continue? Yes or no? They type in a single letter for an answer. We capture that, and then control goes back to the top of the loop, checks their answer to see if its uppercase version is a y, and if it is, then we get to go in again. And so the process is repeated over and over again until finally, when we say, do you wish to continue, they type something other than a y. So if they type N for no, that would go into answer. We would go back to the top of the loop, and we would compare that to the letter uppercase y, discover that it's not the same, therefore that condition is false, the loop is over, we no longer are allowed in, and the program skips down to the bottom of it and then continues on. Here's an example using random numbers. Random numbers can be generated by the computer. They are usually integers. They might be as small as 0 or as large as the largest number that can be integer that can be represented. That's called rand max. Let's say we wanted to write a loop that just printed out a bunch of random numbers between 1 and 100. Here's how you do it. You need to store the random numbers, so we have a random number variable. And then we need to get the random number generator started. The srand command does that. It starts at any kind of random time, and we give it the time. And away we go. Now you notice in this case we didn't ask the user whether they wanted to start this program. We put y into answer right off the bat. And so when we get to the while loop, the condition is true. The uppercase version of answer is uppercase y, so we get to go in. The next statement generates a random number from 1 to 100. You can take a look at it and see if you can figure it out. It's not that difficult. The rand function generates a big integer. We mod it with 100. That means we're going to get what's left over when you take the hundreds out, and that'll be a number from 0 to 99, and then we add 1 to that. Once we've got the random number, we print it. Then we say, do you want to continue, yes or no? And they type in an answer. If they say yes, we go back to the top and we continue, generate another random number. As long as they say yes, when we get to the top, we're allowed in. When they finally say no, then the loop is over. Your author has a number of illustrations of the general form of while loops, and you can see they can have one statement inside of them, although usually they don't. Or they can have many statements. The top version is pretty typical. Now, a while loop is called a pretest loop. You see pretest loops at the left-hand side. This is a flowchart. As the program goes along, eventually we hit a decision point. That's the diamond-shaped thing there. And if the decision is true, we pass into the loop itself and do the statements that are in it, and then come back around to the same decision point. And if the condition is still true, we go in again. When the condition is finally false, we leave. Notice the test is at the top of the loop. We look at the test first before we decide to go in. That's why this is called a pre-test structure, because the entry test happens at the top. We could put it at the bottom, and the example on the right shows that. Here we do a bunch of statements and we get to the test at the bottom, and if our condition is true, we get to go back up and do them again, and there's a test at the bottom, and if the condition is true, we get to go back up again, and we do the statements, and then at the bottom, if the condition is false, we leave. That's called a do-while loop. And this is what that would look like if you wrote the code. Now you notice that the while condition is at the bottom of this statement, and just the word do is at the top, with the statements that you repeat in between. Do the following while some expression is true. Now there are a couple of peculiarities about this particular structure, and you don't see it much. But I should mention them just because a while loop comes in these two different forms, and it's important to know what they are. This version has a semicolon after the while condition at the bottom. Okay, that's very different than most control structures. The other peculiarity about a do-while loop is that there's nothing at the top to screen out, whether it's time to leave. The first time you run a program with a do-while loop, you will always go into the body of the loop, because you don't test anything until the end. That makes these things of limited usefulness. Here's your author's example. They have a program that has a variable ANS, that's the answer. And as you run this program, the program says, hello, do you want another greeting? Press yes or no. And the person types their answer. And then we have a condition at the bottom that looks at what they typed in. And if the condition evaluates it true, they get to go back up to the do and then do this all again. We didn't stop them the first time through to check anything. We just let them drop right into the loop. Also notice the way this while loop condition works. If you didn't use toUpper, this is the way you'd have to do it. You'd have to say, as long as or while the answer is a lowercase y, or the answer is an uppercase Y, then continue. We also have some new operators we should discuss. These will come into play with loops. The plus plus is the incrementation operator. It adds 1 to a variable. So if you have an expression like x equals x plus 1, in other words, have x add 1 to itself, you could just say x plus plus, and it would add 1 to itself. Similarly, the decrementation operator subtracts 1 from a variable. And you can put these in front of a variable. That's called a prefix incrementation operator. Or behind, that would be a postfix version. But either way, they're kind of shortcuts for us to do simple operations like adding or subtracting 1, which we have to do all the time. So now let's take a look at this particular case study that comes from your textbook and see if we can understand the code that they come up with here. In this particular case, you've got a bank charge card with a balance of $50 and you pay 2% per month in interest. How many months would it take before you owed $100 on your card? Well, we could calculate that. You see after 1 month what it would be. Your original 50 plus 2% of it, that would be 51. After 2 months it would be 51. That was your balance in the month before, plus 2% of 51, okay, which would be 5202, and so on and so on. It would build like that. And here's the code. Notice in blue, the while loop, as long as the balance is less than $100, this is going to run. And what's it going to do inside the body of the loop? It's going to compute the new balance, adding 2% each time. It's also going to do one other thing. It's going to add 1 to a counter. This counter is counting how many months we've gone through before the loop leaves. Notice the count variable was set to 0 at the top. And then as we go through the loop, we add 1 every time we're allowed in and calculate a new balance. So when we're finished, this would tell us how many months it took for our $50 charge on the card to increase to $100 because we didn't pay anything off. Now we return to the operator precedence table. Just to do 2 things, to show you the incrementation operators, prefix or postfix. They're very, very high in precedence, right after parentheses. And the reason is we need to determine whether or not something has to be incremented by 1 or decremented before we do the math or anything else. Now the biggest problem with while loops is it's easy to screw these things up. A while loop can become an infinite loop that does not stop if we don't do the right thing. And let's take a look at this example. Here we've got a program that prints the odd numbers that are less than 12. So we'll start with x being set to 1, and as long as it's not 12, we'll let this loop keep running. So x is set to 1. 1 is not equal to 12, so we get to go in, and then we print out x. It prints out 1. Now we add 2 to x. X is now 3. Back around to the top. 3 is not equal to 12, so we print out 3, and now it becomes 5. 5 is not equal to 12, so in we go again, and it prints 5 out, and x now becomes 7. 7 is not equal to 12, so we get into the loop again, and we print out 7. We add 2, it's 9. Back around. 9 is not equal to 12, so go in again. Now it's 11. Back around. 11 is not equal to 12. Go in again. Print out 11. We add 2 to it. Now it's 13. 13 is not equal to 12. And now we're in trouble because it's going to be 13, 15, 17, 19, 21. It's just going to go and go and go and go. There's no way to get out of this loop because x will never ever equal 12. Now we probably should have used, instead of a single value to look at, we probably should have used a range of values. We probably should have said as long as x is less than 12, keep this loop going. So we have to be very careful the way we write loops, or this kind of thing can happen. Here's a situation where x is set to 10, and as long as x is greater than 0, we're going to print it out and subtract 3 from it. So it starts at 10, we print that out, and it goes to 7. 7 is greater than 0, print that out, subtract 3, now it's 4. 4 is greater than 0. We go in, we print 4 out, we subtract 3, now it's 1. 1 is greater than 0, we print that out, we go in. And now, when we subtract 3, x becomes negative 2. When we get back to the top of the loop, x is no longer greater than 0. That expression is false, and we are out. But what if we changed x greater than 0 to something like, as long as x is less than 0? I just flip those. Now what happens? X is set to 10 to begin, and we get to the while loop, and it says as long as 10 is less than 0, well, 10 is not less than 0. That condition is false from the start. If the condition in the while loop is false, you don't enter the loop. What happens if you're not allowed into the loop? Then you skip the whole thing and you go on to whatever statement comes after it in the program. And that's how while loops work. These are really good examples, all of these short ones. You could write programs and test out while loops, just a few lines of code until you really feel like you know them. They're important structures for us to know. They're really important for us to master, especially as we move on to other more complicated things in the near future. So that's it for simple loops, and we'll talk about some not so simple ones in the near future. Thanks for watching.